the MFX surface type. It's mostly used for collision. You can also do different things with it, but basically every object that has a proxy or physical proxy has a surface type assigned to it. It has to be something. If it's set to default, it will actually, I think, give you a warning. So in the material editor, so let me open any material, and so I picked up default because this one has it set up wrong. So the default material does not have it set. You can see the shader that I use for rendering, and then there is a surface type. You can define your own surface types. As you can see, there is like 5 different metal types. So you can define the physical properties of your object. Everything they do, what happens on a collision, how much friction they have, how much bounciness they have, this is all defined in the surface type. And you can have multiple per object. So if you have a chair, it has like maybe wooden legs and then there's a fabric. So you can have multiple properties of surface types per material. You can't have more than one in one submaterial. If you have multiple submaterials, you can have multiple surface types. Basically what happens on each collision, when 2 objects collide, it finds out what kind of surfaces did collide. And first it will calculate what is the friction between these objects, how much they would they bounce off, because they both have a different bounciness. So they bounce off different with different materials. Some absorb more, some do not. And so on. There's a lot of things that can be set. There's down there and there's physical parameters. It's documented. The documentation is missing out some parts. There's a lot of physical properties that you can set. You can also filter out certain collisions. So if object A collides with object B and they have some collision type that is not matching what you said basically there. So you basically say like object A should never collide with something that is player. So object A will always go for a player. It will just ignore the collision. I can show you the file. It's in libs. So game SDK. I extracted it. When you have game SDK, just download it. It's inside game data. The libs folder does contain a couple things. So game data pack, when you extract it, you will get libs, material effects. And this is when you create it from scratch. You should create it always there. It will automatically pick it up from there. It has to be named correctly. So ideally, you would just copy it from game SDK and then you have it. I would recommend when you copy it from game SDK, it has a lot of surface types. So ideally you would just go delete everything except one and then start from scratch and only introduce surface type that you need to. It's not a big performance impact if you have many. It's just way harder to maintain this. This gets a real pain to maintain this if you have a lot of different material types, because essentially what you have to also do, once you do this, this basically defines, oh, this is material arm left. That's how it was called. You can call it anything. This can be fluffy. So you have a material fluffy now. It has a friction of 1.1, elasticity of -2. This is all this described in what it does. It also covers some audio things where you have sound obstruction, how much sound goes through it. Once you do this, it's not enough to have just this file and just make it aware, oh yes, this material does exist, because this will only allow you to make actual the physical interaction. Yes, the friction will be correctly already. The elasticity will be correctly already. So everything that you said here will be already correctly calculated. The physical properties will be correct. But there is another thing that's way more complex, and you will need Excel for this, because the file is set up this way. The MaterialEffects.xml is there to be opened with Excel, and this file is a cross-reference of every material colliding with every other material. And you define what should happen if fluffy collides with concrete, if fluffy collides with metal, if fluffy collides with water, and so on. So every time you add a material there, you have to maintain this table and define what should happen if this material collides with any other material. You don't have to. You can just say nothing happens and it's like you don't care. But then you get no sound, because the sound is dependent on what kind of material is collided. and you will not get any particle effects because there is a different particle effects when different materials collide. So this is why you keep the list small because you will get a lot of data entries here. There's also one thing, the order is top to bottom, left to right, and you have to keep them in the same order. You can't switch like mat wood and mat metal there and then do the other way on the other thing. So it has to be same order. And there are certain things that are not defined by the SurfaceTypes.xml, where you don't define a material here, but you can create a surface type in code for whatever purposes you need, for maybe some kind of special bullets that you spawn. I do have a specific surface type, and you know exactly this bullet will never collide with itself, or you know exactly this bullet is basically not going to be used in certain ways. These you add at the bottom. You only need them in the first column. You don't need them on the right. So basically everything that is in the SurfaceTypes.xml you add in both sides, and everything else goes in the bottom. So basically what they say here is when metal sheet collided with metal water, go into collisions column water default. What it means is it will go into this file in the fx libs in the collision, and then it will go into mud water. It will find mud water default, and it will play this audio, and it will play this particle when this collision happens. And this is basically how you set it up. You go through the things and you kind of think about it. Do I want to actually do this? Because sometimes it's just not needed. But of course, for most of the things you will need it. Otherwise your world will feel very dull, and when things collide, they don't do any audio. You can reuse, of course, these events. If something collides with metal, it always should sound metally, so you always play the same sound, or the same trigger, and so on. There is a lot of things that you can do in this collision. One quick thing, it also spawns the decals. So if a bullet hits something, it spawns the decal there. This is the system that does it. It spawns the particle for the impact. It has some attributes. Oh, I haven't shown attributes actually. It's very important. How you do variations. So now we made a fire, and let's say we made it green fire for whatever reason. Now we want the exact same effect over there. And I just duplicated it. But I don't want the fire to be green. So one thing could be I just redo the whole effect, or I expose some kind of property to the user to make it not green. So what I can do is, in the particle, you can go into the show effect options, click on this. It will, in the inspector, will open attributes. And now you can just add an attribute, and it can be of 4 types. It can be a Boolean, integer, or a color. In this case, we want just color. Default should be green. We need fire color. And what I can do now is, on the color, I can add a modifier again. But this time I don't do a curve or anything. I just add an attribute. And I pick the fire color attribute. Now, since this green gets multiplied with green again, I just go back to white. So I have now my green. And what I can do right now is then, when I have the emitter selected, and I go just into the properties of the emitter, when I have the emitter selected, I will see that right there, I have now fire color exposed as a property. And I can simply change it to whatever color I want. And now I have 2 different variations of this. And you can do the same thing with not only with color, but with anything that you can put a modifier on. So if I want the size, I can just add an attribute here. Oh wait, I need add an attribute. It's a float value. I give it a default value by 1. Fire size. And you can min-max even this. It's like it should be never less than 0.5 and never bigger than 5. And in the size, I go attribute fire size. And now I can make this one 5 and this one 0.5. And with also, because I set a limit, it will never go. It will never go below this number. If I set it to 0, it will clamp to 0.5. And this thing does not need to be an attribute. It can also be a curve with the input of an attribute. So you can even, when the value comes in, you can interpret the value to a different value. So it does not need to be linearly scaled. So you can have a custom curve, basically what it does. And combined, when you do a complex effect, you just have one attribute that changes the whole effect. Because you can reuse this attribute everywhere, and you just apply a custom curve and you basically have a number from 0 to 1. And you can completely change the effect by that. And it will not only scale it up or something, it will actually move the things or whatever. The target feature is also maybe useful for a lot of applications. Here I have a particle that has a target. And I have the lifetime too long. So basically, this is the beginning and this is the end point. And right now it's only set up to do this noisy thing and very overlapping timing-wise, but you can also do some kind of beam arcs if you do the rate fast enough. How it's set up is basically on your emitter. There is a thing called entity links, which is not a hierarchy link. It's not a actually physical link. They just referencing each other. And then in the property, you just, if it comes like this, so it's default now, you go pick, you pick the target, which is there. Now nothing happens. You have to call the thing target. And then once you do this, it allows you to use some features that, like location beam, will have the source, basically the parent, and then destination should be the target. So there's two things that you can do this. You can do the beam with this. So you can just go towards the thing. Or if we disable the beam, and in the physics, I add a gravity, and I say there is a, and I give it enough time, and I say this is a very strong gravity. So now they will shoot towards the target, and they will stay in orbit if they ever reach an orbit. Right now they're shooting directly at it, so there is no orbit that exists. So yeah, there's some things that you can do with a target. This can be applied in code. It can be spawned dynamically. So you can switch the target. There's some code for this to create an entity link. So you can have some target that you go to, and then you just switch it, and it just goes immediately to the other one. Some things do not rely on time, like material setups and stuff. So you can still tweak some values, especially when it comes to when I explained how the sorting works. It's sometimes really hard to grasp when explosion happens and it's just like 0.1 second on the screen. The sorting can be tweaked and the timescale 0. So you can just freeze the explosion, and then you sort everything that how you want it to be, and then you just continue. You can set it a value to anything, like it could be 0.1, so you have some very slow moving time, and then you can look at it in more relaxed way. I can quickly go through the most important one. Our profiler 2 will give you the rendering profiler. You should look out for forward transparency. That's the most cost that you will get, except for raycasts. Like raycast and forward transparency, this is the one that you want to deal with. Essentially, it's just like don't have a lot of sprites overlap. Pretty basic. So there's that. There's eParticles debug. If you set it to B, you get bounding boxes. of particles, so you know how big the bounding box are. So you can see there's like in this area there's a lot of going on. So maybe you should consider looking into this area or something to find effects. Otherwise, if you set it to 1 and you have our display info on, you will get also these things where you can see how many emitters are running, how many allocated and everything. So it's the first thing to go to find out how many stuff you actually have running.